Welcome, my name is Ali, and today I'm going to talk about healthcare and government expenditure. First of all, let's talk about why I'm doing this in the first place. Over the past centuries, countries all over the world developed their own healthcare systems differently. So since then, they have not been in agreement as to which system is the most efficient in terms of government spending. So today, I am going to analyze the healthcare systems of these countries across 6 continents and to see how the government expenditure affects the efficiency of healthcare system. So the government expenditure is going to be measured in terms of percent GDP, and that's straightforward because that's how a country spends on healthcare. I'm going to use life expectancy as a measure of healthcare efficiency. And the reason because life expectancy is really used across many different credible organizations such as the OECD and the United Nations. So it makes sense to use that to determine whether a healthcare system works or not. Here is what I hypothesize. As countries start spending more on healthcare, people's lives start improving and they start to live longer. So, as GDP expenditure on healthcare increases, so does life expectancy. And this is a cause and effect relationship because in this case, the cause is going to be percent GDP expenditure, right? And the effect is going to be how the percent GDP expenditure affects life expectancy, right? So as that increases, the other increases. As GDP expenditure decreases, life expectancy begins to decrease as well. Already, data collection. The data that I collected are secondary data because I do not have any access to primary data, of course. And the data I sourced are actually from credible organizations such as the OECD and the United Nations. So there are no any subjective or biased data because I want to maintain the integrity of my research, of course. However, most of the countries that I picked in the sample are honestly European countries because they have available data, right? But some countries and parts of Africa and Asia, I could not have any modern and factual data at least. So I did not use most of them. In turn, that means this study is going to be more applicable to parts of Europe and North America as opposed to some parts of Africa and Asia. It might not work in there because, like I said, there was not enough data to sort in the first place. As you can see, my data are looking very ugly here. That's a lot of them. What I did, I separate them by healthcare system just to show you that I diversified my data. So I did not just pick all countries of the same healthcare system. And that's just so that, to reflect the to reflect the population more properly. The two different variables, as you can see, are life expectancy and percent GDP expenditure. Now, I want to point out that I used different years for a reason. So, as you can see, percent GDP expenditure is 2010, while life expectancy is 6 years afterwards. And there's a reason behind that. The change in percent GDP expenditure does not reflect immediately in the life expectancy. So, what I did is I picked about like 10 years before so that there is enough time to reflect the change in life expectancy. Now, measures of central tendency. As you can see, the average life expectancy is 80.7 years, while the average percent GDP expenditure is 8.4%. Now, I want you to note that the first average is measured in terms of the median because the data are negatively skewed, as you can see in the histogram over here. While the second average is measured in terms of the mean because, well, the data are normally distributed, so honestly, the mean or median or the mode, they're all kind of the same. They fall about in the center, in the in the interval between 6.60 to 9.90. So I just picked the mean because it is more reflective as we talk about money and such. Now, we're going to talk about measures of spread. That is how spread the data are, obviously. Now, judging by the numbers, you can see that life expectancies are highly dispersed, while the expenditure numbers are way less spread. In other words, most countries on the sample have a life expectancy between 76 and 83, while the rest are spread out over the interval 55 through 92. Also, it appears that in terms of spending, countries can be classified into different groups depending on their spending. That's what you saw in the histogram before. And most of the countries fall into the 5.59.90 interval, as I pointed out earlier. Okay, now I want to show you something important about the quartiles. Now, look at this table for now. You see we have different quartiles in interquartile range for both variables. Now what I'm going to do, I'm going to use this table to find the outliers. Now remember, the equation to find outliers is what? Well, it is, we have to determine a range, and that range has two bounds, lower and upper. So to find the lower bound, you take the first quartile, subtract the interquartile range times 1.5. To find the upper bound, you take the third quartile and you add to it the interquartile range times 1.5. Now, once we did that to both variables, we found that India and Sierra Leone, these are two Asian countries, both of them were lower than the lower bound. And as you can see, 57.4 is Sierra Leone and 68.5 is India. And we did the same for the percent GDP expenditure, and we found Sierra Leone again being another outlier, as it is lower than the lower bound, as it spends nothing at all on healthcare system, on its healthcare. And while you have the United States exceeding the range through the upper bound, because it is spending way more on healthcare than the other countries, as it is pointed out to be 16%. Now, what does that really mean? Is that the United States spends 86% more than average. See, that's a lot more than you would expect. And then Sierra Leone's life expectancy is the lowest among sample nations, followed by India. That's really all what the outliers tell us. Well, now we're going to examine the two variables against each other. So as you can see, I produced this table, and first of all, let me talk about what I really did. So I ran multiple correlation tests and regression analyses, and then I found there was a moderate positive correlation, linear correlation between percent GDP expenditure and life expectancy. But then, you see, I didn't like how most of the points are really above the line, and it's just that there is no correlation. When you look at it visually, you don't see that correlation, and you're like, yeah, that's really correlated. There is a relationship. No, I thought, hey, I got to do something else. So I did a quadratic regression, and lo and behold, the curve runs through most of the points, and when you compare the r-squared value, it tells you for sure. For the linear, it's 0.495, while for the quadratic, it's 0.843. And that's just, it's mind-blowing as it is. I will talk later about the implication of the quadratic model, but I just want you to look at the correlation and the r value. So one more point, though. For the quadratic model, it doesn't have an r coefficient because the r coefficient is strictly for linear relationships, and therefore it doesn't. But you can compare the r-squared for both of them, and you can see that the quadratic model is has way more correlation, which is nice. Now you can see we have two equations. E at h is equal to 1.31 h plus 68.1 for the linear model, and for the quadratic we have E at h equals negative 0.191 h squared plus 4.35 h plus 57.6. I want to point out that E is life expectancy and h is percent GDP expenditure. I still need to point out that, as it turns out, as the country begins spending more than needed on healthcare, it's a sign that their healthcare system is inefficient because life expectancy is going lower than other countries that spend less on healthcare. I also did a residual analysis just to confirm what I already know about the R coefficient, because they tell you the correlation. So when I did the residual plots for both models, you can see that the quadratic model has most of the point closer to the x-axis or the horizontal axis, as opposed to the linear model, where you see the data are really, the points are. So if you look at the y equals 5, a line on both plots, you can see that for the linear model, we have the points are exceeding y equals 5, while on the quadratic model, we can see the points actually sitting on y equals 5. And then if you look from the other side, from the negative side as well, you can see that this one point on the linear model is not just that, you have the negative 10 as well. So y equals negative 10. You can see one point is below y equals negative 10 and a little above y equals negative 10. And then you have one point well below y equals negative 5. But if you check the quadratic model, you see the lowest point actually is well above y equals negative 5. So you can see that the quadratic model, the points are well close to the the horizontal axis, which indicates that it is a better correlation than the linear model. Now, in conclusion, I just want to say that the initial thought that percent GDP expenditure on healthcare correlates positively with life expectancy, that all appears to be unsubstantiated after the analysis that we saw. And it turns out there's an optimal GDP percentage shared by most developed nations. This optimal point indicates the top efficiency of healthcare. This is rather surprising because it is counterintuitive to think that the more expenditure implies less productiveness, right? However, it turns out there is a logical conclusion you can draw from this result. Countries that have private sector acting as a middleman between the government and the people causes the government to spend more money on jobs the private sector charges excessively for, when the government itself can do the job cost. So, put simply, really, the government can rely on itself to do most of the services of distribution and delivery of healthcare drugs and services without having to rely on the private sector, because if they do, the private sector basically charges for profits, and if it does, the government has to pay way more than it really needs to cover operation costs. So that is really the point drawn. So in other words, really, I mean, if we want to look at examples, the United States, it appears to have one of the most inefficient healthcare systems, because despite that they're spending 86% more than average on healthcare, as we saw earlier, they have a life expectancy of 79.8 years, which actually puts them in the lower 50% countries. That is below the median. And it is unfortunate, really, by the way. And to summarize, there is a polynomial relationship between percent GDP expenditure and life expectancy, and it is best modeled by a quadratic function. To improve the project, we want to make it more applicable to other countries, and for that purpose, we will need more data on countries in Africa and Asia. If that happens, we can make this study even more applicable to other parts in the world. Thank you for listening. And for the students who are to rate me, please ensure that if you have any questions, just ask. Don't be shy, because I want all the marks. I want to make sure that you give me a good rating, all right?